I think
Yeah.
we have a nice surprise with Chuck in the meeting. I am super happy because I sent him an email. I sent also an invitation to many different people from the FORTH community, important people, and it's a great honor to have Chuck. So if we can ask him whatever you want, people, and this and keep going. What do you think?
Yeah, I have a question. When I saw a demonstration of you, Chuck, of your system, you're mainly focusing on loading source code. Of course, presenting a running system, but you have this notion of apps that are defined in source code. And if you want to switch from app to app, it's not that you load binaries, but you just load source code, and you have something like remember also that prunes down the dictionary, and then it loads up the new application. Do you think this is the favorite way to deal with FORTH?
I don't understand. Moving source code from one system to another?
No, yeah. I saw that the apps, the applications that you use in your system, they are not loaded inside the system and you switch between them, but whenever you want to use an application, you just load the appropriate blocks, and then the application is available. So you keep them in source code and not in binary code. And I think this is rather different than what we do with operating systems, where we have all these binaries and don't rely on source code, but there's this compilation step and we have to manage binaries, and using source code seems to be much easier for me.
Yes, that's exactly right. I keep everything in source code except for the kernel, and recompile it as needed. Now, in FORTH, compile takes 0 time, milliseconds. So there's no reason not to recompile. And that makes it a lot easier to edit and a lot easier to maintain the current system. For instance, my apps use the word load a lot, and loads a block of source code, compiles a block of source code. Apps share blocks amongst them. For instance, I have one block called random. It generates random numbers. And anyone that needs a random number just loads that block. It makes things clean and, again, easy to maintain. If I need to change random numbers, they're changed everywhere. Incidentally, I've been thinking recently about the word load. I would say something like 70 load. And that's a very old word. It goes way back to probably 68. I'm thinking of renaming it read, since that's really what it's doing. It's reading a block and doing what that block instructs, which is not always to compile code. Sometimes it's to interpret a database, or in the case of AI, to generate a language model. On the other hand, it's a lot of trouble to rename something. I probably never get around to it.
I find it always hard to remember on which block certain source code is. So we were broadly discussing to have a word need, where you just say need, word name, and then the system figures out by itself where word name is defined and then loads the appropriate snippet of code. Do you think that would be a good idea?
Oh, yes. I have an index block that names a lot of my apps, and it names them by the block that you load to get them.
I see.
I don't actually name the what micro block call them, like the random. I don't have it named random, and I don't remember what its number is, but I would look up an app that uses it and pick the number off of that. I don't create new apps very often, so it isn't worth making it too easy.
I see. Thank you very much.
I have a question for Chuck, a very simple, a very easy question. Chuck, where do you recommend the FORTH 2020 group that we should explore promoting force? In which fields do you think we should put the emphasis of our promotion of force?
I've always admired space travel. So I think that force should be brought to the attention of Musk. And I've tried to do that a couple of times, and he can't get through his my interest at the moment is mostly in nutrition. I am 86 now, 86 and 62 days, I think. And in the interest of extending that, I try to eat healthy. And I've devised a couple of apps that let me track the nutritional value of the various foods, mostly the foods that I eat. And that's due for an update because I've learned a lot more about the value of various nutrients and supplements. I don't think there's a community out there interested in computers, but it might be the converse, that the FORTH community should take more interest in that. I commend to you all the value of nutrition.
Getting back to the space exploration with force, do you think Musk or anyone who wants to explore Mars, for example, they will have requirements of low energy? So would, for example, green arrays, GA144, being the processor for Mars, or do you think this is this would be the GA144 would be a good example of what you are saying?
I don't know that they care that much about energy. They've got lots of solar, lots of nuclear. But what I think they should care about is software. FORTH software is 1/10, at least 1/10 the size of conventional software. And it's got many, many fewer bugs. And that should be very important to them. And they don't know it.
So another one with questions to Chuck. Fire. Fire more questions. Albert, you are still.
Why shouldn't the Aye.
You know, this question of reliability and as far as space applications go, do you remember why Ariane 5 went down? It was an arithmetic overflow, and this is very, very difficult to test for. And I'm not sure FORTH applications are more immune to that than in any other language.
Sorry, I missed the question.
How do we validate things like floating point libraries? Are there any known methods for this?
I have a library. For instance, one of my blocks deals with trig functions. And it only takes a block of code to define sine, cosine, arctangent, square root. And that's all I need. The C libraries are huge and ancient. And there are better algorithms for calculating the things they calculate, but everybody copies it. I'm a great believer in reinventing the wheel. And it isn't that hard. And you can take a great deal of satisfaction in computing your own sine code.
So essentially, you have time-tested libraries which you rely on.
Yep. I have a fast Fourier transform block, which I don't use. It was just an exercise. I have a JPEG block. Some of them, what was I doing recently that I gave up on? Screen capture with the common graphic format. Some of them can be really challenging because they're badly documented. And you have to figure out how to do something that's compatible with the greater ecology. But it's fun. That's what programming is all about. And of course, we can share code. I have uploaded a lot of applications. I don't know anyone pays any attention to them, but when I had my web page, I would post source code. I don't know how compatible FORTH systems are at the moment, but it isn't hard to translate from one version to another.
This is something that I always think. People make so much problem when they say FORTH is not compatible. My FORTH is not compatible to the other. For me, it's so easy to make it compatible. Normally, there are only 2 or 3 words that don't work, but all the rest is the same. And if it's not the same, it's not FORTH. And if it's force, it's easy to add. So you can add at the console, basically. You can type at the console and try out. And if it doesn't work, you do it again. So it's so simple.
Right. That's one of the advantages of breaking source code up into blocks. You can borrow someone else's block of code, which is only like 16, 30 lines, and work on that. If you get a whole file full of source code, I can see that being a challenge.
I have a little question. It's a bit dangerous, if you don't mind. Have you ever seen or tried BASIC?
Way back in the day, I programmed some BASIC.
And what was your opinion at that time?
Say again?
What was your opinion at that time about BASIC?
Oh, it was too simplistic.
Okay.
It was like in my mind to the turtle code that people played with. Again, it was just too stupid to be useful.
Okay, thank you.
Can I ask a question? Can I ask a question?
Don't need to ask, Alvaro. Go ahead.
Recently, I made a model of thread code for FORTH that comes with all primitives on one part of memory and all composed words above that part. And there is no need for CFA and no need for the call at head of composed words. Can it be an alternative for use in common ways? Sorry,
I didn't understand.
I can't. Sorry, Peter. Could you help me? My English is not so good.
Say in Portuguese, if I can understand you, because I think it's a very complicated question.
Okay.
But I will try, Álvaro.
Eu montei novo modelo de código por FORTH. Nesse modelo, todas as primitivas ficam num bloco de memória e as compostas ficam em outro bloco de memória. Nesse modelo, não tem necessidade de ter um CFA e nem de ter do call no início das palavras. Então, fica um pouco mais rápido e um bocado mais eficiente no sentido de espaço. Eu queria, se fosse possível, a opinião dele sobre isso.
Okay, I will try to translate.
Sorry,
Álvaro made a new type of force, he thinks, and the primitives are in one block, separated from the rest. He has no do call and no CFA, no column field area. He thinks it's faster, and he wants to know your opinion.
Say again.
It's a force with primitives in one block. And what was the other, Álvaro? Primitives
The
in one
other
block?
is all other ones. The block, the upper block of memory is for composite words.
Composite words, okay.
Yeah.
He puts the composite words in the upper part of memory, and the primitives in one block. There is no do call and not call CFA. There is no CFA, column field area. So he thinks it's a faster model.
I don't know why it would be faster. Segregating things is a good idea from a pedagogical point of view. Speed of compile is not important. Speed of execution is the only criteria, because compile is done rarely and is very fast anyway.
Okay.
I don't think I truly understood the question, and I don't think I answered it, but sorry about that.
No, me neither, Chuck. It's a bit complex, and maybe Álvaro should make a diagram of his force and explain. But this could be made in another session, not today.
Okay. Okay. Sorry.
But the answer was okay. I think it's
Yeah.
interesting. The answer was interesting.
Yes, it's correct. But it is a little faster on my tests.
Well, we have in the meeting Rob Probing, and he did not make any questions to Chuck, and he's losing the opportunity. And Cornelius, which has a nice Novix chip, will lose the opportunity. And Richard is laughing, but does not make any questions to Chuck.
I do have a question, I think, that might be interesting. So I am fascinated with distributed controls, and I'm wondering, Chuck, if you've had any experience with putting a system together where you had to make a choice between using one complex processor or distributing the control for that system through simpler, smaller processors and communicating with each processor.
I went through that a long time ago, back in the telescope days. I was firmly convinced that you should have a single central computer doing everything. And I could do that in FORTH. I could handle more peripherals than other languages. So I didn't like the idea of having a lot of little computers around. After a while, I changed my mind. I thought a lot of little computers were great. They could all be programmed in FORTH and talk to one another, and no one was very complicated. You didn't have to have multi-programming or time sharing or anything. That is my current opinion. I think that a robot should have computers in his knees, in his elbows, in his wrists, in his head. And they should all be simple and talk to one another, but not any more than necessary. You tell the knee what you want it to do, and it figures out how to do it. This gives you a lot of fail-safe.
Right. And then it also lets a person that's a knee expert program his knee in his own way. And then the vision expert can program the vision in their own way. And then you could, in theory, you could have distributed words that say, find ball, you know, approach ball, pick up ball, right? And those words could then be like I said, you know, some of those processes could be really complex, and you could let the domain expert for gripper articulation manage that domain, and then define words that other people could use for that, for his particular specialty. So I really like that idea. I think it's, and I think that FORTH is inherently a communication and M2M communications architecture, because the console forces you to be able to communicate with a device. And so I think that's really cool. So have you had any experience with bus arbitration in that scenario?
Again, a long time ago, we had computers talking to each other. It's a hard problem because there's all kinds of not very good solutions. I wonder, does anyone know how Tesla programs their robots? Do they have central computer or distributed? Again, it would be, I think, of interest to them to talk to us about it.
Thank you. I appreciate it.
If they are like their cars, then you have a crap ton of controllers all over creation, hooked together on a central, somewhat proprietary bus.
Well, there is the CAN bus.
They don't use CAN bus anymore. They use a internet site bus.
But it's still a standard bus for inter-process communication on a vehicle, is it?
Yes, it is, and you have a huge installed base. So to get away from a huge installed base, it requires a forklift or a new company.
I've got a related question to Richard's question, which is, Chuck, I mean, you worked on a whole bunch of different systems. I've tended to find that FORTH is quite a good glue. Ulrich and others were talking about sort of AI, that where they used Python for glue to glue a bunch of, you know, libraries together in various languages, including C++ and FORTran and other language. I've tended to find that the FORTH often has got a place, whether it's on a particular micro running a particular job, or sort of a communication interface, or sometimes if you, for instance, with factory test, they want a factory test script, but that you don't really want to. A lot of people, when they do it, they just write a fixed set of sequences. But often when it gets into factory, it's more complicated that or need modification. So I've tended to write, for instance, factory test interfaces in FORTH, and I've ended up, and I've done bits of work on computer games, and I've ended up in this situation that FORTH's quite a good it often has to interface with other systems and other programming languages in maybe unexpected ways. And I mean, I've found it quite good because there's a lot of flexibility with how you actually design the Forth, you know, what it's running on. Is it running on sort of a high level existing architecture? Is it running bare metal? Did you have experience of this sort of multi-system where you might be dealing with other people's modules and other programming languages during your career, Chuck?
Yeah, one incident comes to mind. I needed to communicate with a peripheral, and it basically used serial protocol, and this was at a remote site. I was in Cleveland or somewhere. I got my side of the communication up in half an hour, and I looped it back, so I knew it was working. I could communicate both ways through it. And the guy at the other end took a week to make it work. He had no way of testing. And all I could say is, it isn't working. So yeah, if you're in the Forth universe, you like to stay there because even if you're talking to someone else, you can talk. When you're dealing with someone who has to recompile an application, it takes half an hour. It really hurts.
Yeah, I agree. I mean, testability in Forth is excellent, right? It does. I mean, you've got a whole bunch of, you can just go on the command line and interactively figure out what's the problem and what's the solution. And I think you've talked about this before, Chuck, in books, about the fact that you can test as you go. You can figure out the problem that you're trying to solve. Which is, I mean, it's not always clear what problem you are trying to solve. That's one of the things I've found over the decades. People think they know, but it's only when you've written something do you actually know what the problem is.
Well, Forth lets you communicate to a computer in source language. So you're actually talking Forth to it. No other language has this ability. You have to translate into something else in order to test, and that's just unnecessary.
Yeah. I mean, even the more modern languages, which are more dynamic and sort of much more close to sort of Forth and Lisp's interactivity. You can't. I mean, they've got some benefits, right? I mean, but conversely, you can't just put it on it's tricky to send, for instance, Python strings to a machine, right? I mean, it's not really written. Whereas Forth, humans can use it and machines can use it. It's got this interesting duality in the fact that you're very close to the machine, but you can build this, I think you've said this before, you can build a very high level model to work with. And that was the other thing with Forth. And you can get other machines to use this high level model as well. It's not just an interface for humans. That was always something very interesting.
I was wondering if I could ask a question of Chuck. Chuck, I'm a longtime retired educator, and I've used Forth in teaching middle school kids and high school kids and even college students on using Forth. I started back with Atari 800 with the Fig Forth. I think that was 79. And later the Forth for the PC, FPC 83. And I used those successfully in my classes with very rudimentary words that I created that they repeated, mainly with robots, little buggy robots and so forth. And I'm just wondering, do you have any experience in the past of working with kids or how to approach kids in teaching them Forth?
No, I'm not a teacher. The very best I can do is provide an example and hope that they can learn from it. I do recall one experiment that was done teaching kids programming, and they would teach them something like BASIC and then teach them Forth and vice versa. And the kids who learned BASIC first were most annoyed that they were taught the wrong thing.
I love it. And I think my experience has been the same. I did find I worked with special ed teachers and their students, and they picked up on Forth so easily. I was amazed. I mean, you know, more so than the regular population, if you want to say it that way. Somehow that connected with them. So I found that a learning experience for me and said, wow, if that can happen, then Forth is probably the way to go. But I appreciate talking to you and very proud to have met you.
Thank you. Well, Forth is not a trivial language. It's a simple language, but by the time you mastered Forth, you've got a vocabulary of hundreds or thousands of words. So there's a learning curve involved. And it's a different curve for other languages where you have to learn the syntax. In Forth, you have to learn the semantics.
Yeah. Love it. Thank you.
Just as a note, so I've taught various programming languages to children, but I know somebody who's actually a member of the FORTH2020 group that he teaches Forth to I guess they're 12 to 15-year-olds in robotics. So his preferred, he made a business for Forth. He built educational robots in the UK, and all his educational robots were written in Forth. But now he's retired. He runs robotics clubs, and he teaches Forth as a first language in robots, and the kids pick it up no problem at all. It's not been a problem for him at all. I'd convince him maybe to do a talk to FORTH2020, but it's not been a problem in his experience. So
Is it
Yeah, I
called
have a similar
Bennett?
experience.
Is
Sorry.
it called Bennett?
no,
Because he teaches Forth as a first programming language to kids from 5 and over. And it seems to be working very well for him. He's retired as well. He lives in the UK. Exeter, I think.
no.
I've met him recently, and he's a fantastic engineer.
Yeah, this is a guy called Duncan, and he's involved in. I'm involved in the Micro Mouse community, the maze robot solving, and he's been doing that for years as well. So, but maybe I'll get him to do a talk at some later date, convince him.
I have an anecdote to complement this story. I had a friend with no experience for computers, and I bought a Jupyter Ace, so no other language as Forth. He came weekly to me for lessons, and after a month, he demonstrated a program, and it was a Pong game. You remember this ball bouncing on the sides of the screen and the thing, but he was not aware that programming a game is considered something difficult. But he looked at it and he made it. Of course, it was a very intelligent guy, but never mind.
Oh, the good old Jupiter Ace.
I had a question for Chuck. Chuck, do you have any plans for your website? I noticed maybe about a year ago there was a little bit of material there, and now it seems down at the moment. Curious if you have any plans for colorforth.com.
Yeah, I tried to revive it, but I just wasn't enjoying the process, and I gave it up. I'm beyond the point in which I want to promote Forth and communicate. I'm retired. That's actually a problem. Too many of us Forthers are retired. Where are the young people?
Thank you. I wondered. It looked like you'd had a start at it and then sort of thought better of it. So.
The young
Yeah.
people are learning Python, unfortunately, and the misguided ones C#.
Oh, Cornelius, there is a question in the group, in the chat. Can you read it for Chuck?
Let me find that real quick.
I don't have.
Okay, come on, where is
Oh.
it? Okay.
I didn't have the chat displayed.
I have it. From Jen Chu. I have a small question for dear Mr. Chuck. Could we develop some WRS, probably words, for control the program data input or output for AI? There are many cores residing in every one graphics card. They could be controlled by CUDA and C. And can we define some standards commands for our Forth to send data into the cores and harvest the results to complete our AI design? So the way I understand it is there a way for a Forth program or to augment a Forth environment with client stubs so that you can talk to CUDA code running in a graphics card?
That's not the kind of question I can answer. It's the kind of question I would ask. I'm confident that Forth can do anything, but I certainly don't know how to communicate with an AI.
Now, CUDA is not AI. CUDA is just massive parallel programming in a very proprietary environment. So AI installations use graphics cards simply because they have a boatload of CPUs in them to make the heavy lifting easier, because AI requires computing at scale, and graphics cards are good at that.
Yeah.
And graphics cards, NVIDIA rules the roost, and NVIDIA does CUDA. So go ahead.
And you need tons of low precision floating point computations in AI.
Yeah.
And which is graphics cards are good at.
Yes. You just have to construct an interface that you can talk to the C environment that these things run on, because unfortunately they come as a very big bundle. Would be nice to run Forth on all that stuff directly.
I have a question for you, Cornelius, since you seem to know what you're talking about. Has CUDA been standardized as of yet?
I don't think so, simply because it's one outfit driving it. So it's like with Microsoft, you get a pseudo standard, and if somebody wants to play with it, They better treat it as a standard.
So it's a de facto standard.
Yep. That.
That kind of sucks.
No kidding.
Are you still there? Chuck Moore, are you still there?
Yeah.
Well, no, I was just wondering what you have been doing with, because you spoke about distributed systems and also multitasking. Well, what have you been doing with this?
Nothing recently. I've abandoned multi-programming in favor of dedicated applications, one at a time. I can only pay attention to one thing at a time. And mostly what I'm using Forth for is my own information.
Okay, so this explains why I haven't seen this. I haven't seen a single preemptive multitasking Forth with synchronization primitive. So I just wanted to build that just to make sure that it was possible.
There is an example of the use of that in my GitHub account, and that is present under the primes GitHub, and that is calculating how many primes there are under zillion, and that is that takes a lot of time, and then it is useful to separate the computing in my two separate processes. I have a 8-core AMD processor, and approximately it is useful to split it 5 ways. Approximately, you could split it 8 ways, but then it becomes slower. And of course, you could split it 30 ways and then have the processes write files, but that is more of an exercise, and it will work probably. I think it most useful would be if you have a server and there are messages coming from more than several clients to separate it that way, and then you can profit from what Chuck Moore says. You could think about one communication at a time and not worry about other things.
Yes, I tried with the primes. I did the sieve, and then I had one thread print all the 2s, or to store them in the array. Then the next thread would store all the 3s, then all the 5s, and then it would go and the main task would go and look for the first unoccupied place in the array and decide it was a prime. So I left 56 threads just run wild. And
was it faster?
Well, I printed 100 million primes in 16 seconds. The problem was that the last one was not a prime, because they you know, the less they have to do, the faster they run. So the last ones had overtaken the ones that that were before them, so that there was unoccupied spaces that they hadn't managed to fill yet, and it would incorrectly flag that as a prime. I put it up on YouTube, and some guy pointed it out to me that there was a serious bug in it, but it was just these tasks running wild. And that's when I started to think about synchronization primitives.
Yeah.
Okay.